So one of the goals of these is to do presentation each month and try and keep the presentations down to about 30 minutes. That way, if any other clubs want to join, we're done before they try to have their nets later in the evening. So this one's going to be on making some 2-meter and 70-centimeter antennas, and we'll just keep it going from there. There will be a workshop, and actually this is wrong, it's April 12th at 10:30 here at the club for anybody who wants to actually build the antennas. And if you're a club member, you get to walk out with the tape measure antenna. It doesn't cost you anything. If you want to do one of the more advanced antennas we have, let us know. We'll make sure we have the supplies, and we'll let you know. Cost on any of them are going to be under $50, so we'll go through that. All right. So one of the things they're going to, depending on which antenna you want to build, is sort of how you want to use it. So for example, if you want to use the antenna for fox hunts, and we're going to have a fox hunt presentation next month, and then we're going to follow that with an actual fox hunt in April. So next month they'll go through, this is how you do a fox hunt, this is what a fox hunt is all about, give us all the information, and then we'll actually do one. But you can actually build an antenna that you use for the fox hunt. Now, with a fox hunt, you want an antenna that doesn't have a whole lot of gain on the back end of it. You want pretty much forward gain on it. And some of the sensitivity makes a difference. So this is an example of one that's on the web for a fox hunt that's real easy to build. And the reason it's only 2 elements is if you put a third element on this, you get more backward gain off of it. So it sort of comes more directional in the area you're pointing by just having 2 elements to it. And we'll go through some of that. Okay, satellite communications. You're going to need both 440 and 145 megahertz to talk to satellites, and they have to be polarized differently. So we'll go through that. Your HT. This little guy will hit a repeater 12 miles away from here with a bowfang. So you may want to increase the range of your HT that you're doing at home. You're just got your tech license. All you do is want to go buy a $25 HT. One of these antennas can help you do that. So a lot of different ways to do it. And then of course, what's your budget and how much is it going to weigh? Because if you're holding an antenna and you're holding it out like this for some reason, like tracking a satellite, they can get heavy quick. So the weight is considered. And then the strength, if you're going to mount it up someplace, can it withstand the wind? You're going to be concerned with what kind of gain you're going to get, what kind of forward to backward ratio you're going to have on it, what the SWR of the antenna is. And so we're going to give you a couple different designs that sort of address all of those. The other one is, it's not on here, maybe it's on the next slide. Yep, it is. You can have an antenna that all of the elements are the same length. This is going to be very specific to a frequency. But if I change the length of the elements, then I change it to a log periodic, and it increases the bandwidth that I'm going to be using the antenna for. You know, your satellites, you're pretty narrow bandwidth of what you're going to look for. But if you're trying to hit some repeaters, you want to hit one up at 147 and one at 45, you may want to look at the log periodic side. So we'll look at some of those things as well. Today, anything that looks like a Yagi is pretty much referred to as a Yagi. But a lot of them, if you see a difference in the size of the elements, then they're log periodic. And by the way, any of you guys can correct me as we go through this. I'm a beginner at all this. And so if I make mistakes, let me know. So there's some math, but the math really doesn't matter unless you want to look at the math. I mean, if you're a person that gets up on looking at math, the math of how you calculate a director or reflector on one of these antennas, well published all over the web. The math about how you do the matching between the antenna and your feed line, all over the web on it. But it's also a lot of tools already on the web that will help you do some of that. And I'll show you some of those calculators in a minute. But you can tell it, I want this frequency, I've got this much room to play with, and it will sit there and tell you exactly the length of the elements you have to deal with. So as we're dealing with one of these, you're going to have one element that's going to be powered, you're going to have one element that's actually, this is going to radiate to that element, and then you have a reflector, and you've made a Yagi. So the calculator, and you may not be able to see this real well, I put in a frequency, and once I put in that frequency, it comes down and populates the rest. But then you start looking at the diameter of the elements, or the diameter of the boom. The answer to that is, what do you have in your garage? If you've got copper pipe laying around in your garage, you can make an antenna out of it. You can make an antenna out of the spokes from your kid's bike if you want to. So these calculators allow you to adjust the diameters that you're looking at, tell you whether the elements are isolated from the boom, and I'll show you some that are and some that aren't. This one is not isolated. They're connected directly to the boom. This one is isolated. And so it changes the measurements, and it changes how far apart the individual pieces are. But when you put that in, it comes out, it will tell you the length of every one of the elements and the distance apart they have to be. Real easy to make an antenna after that point. Oh, by the way, I have little websites at the bottoms of all of these. If you go to any of those websites, that's where this calculator is. Later on, almost every one of these has a YouTube presentation with it as well. If you want to build this arrow antenna, it's not too tough, but there's also a 20-minute video on it. Tells you how to build this thing called a gamma match here, the length of the antennas, the best way to trim them, all kinds of stuff. So this is sort of an overview to get you started. You can take this video home and go and make your antenna on your own, or you can come to the workshop. Workshop will be fun. So this little antenna is a real interesting antenna because he works really well. He has a really low SWR, and he's super easy to make. All of these little pieces that are holding these center rods are printed on a 3D printer. 3D printers have a little file called an STL file that is basically the template on how you build that. You can go to your local library with the STL file and print out these pieces at your local library. This top piece is a $10 piece available on Amazon, and it actually has the connection all the way to your SMA and the wire on it. So on this one, that's my driven element. Real easy to build. This little piece is an extruded piece of aluminum that these just slide in and on. This one you can build faster than the others. He's real strong, and he has a 10 dB gain to him. So not a bad little antenna to play with. But this was actually from a website, and they sit here and they published it out and said, okay, if you want to deal with inches, if you want to deal with centimeters, and it tells you the length of each one of the pieces, the distance between them, or the distance from the end. Distance from the end is fine. It helps a lot. This is like 2 centimeters from the end, and then this one's like 13 centimeters from this one. I just lay out a tape measure, slide these back and forth, tighten them down, and you're done. So that helps a lot. But this is the same kind of thing you get from the calculator. This one was just published either for a 440 or 435 megahertz antenna, so you can adjust it whichever way you want. You might want to just use this for a scanner like Brian would, or you might want to use it to talk to a satellite. There are lots of, this website, DW1ZW, is a great website. This is a guy that is, I forget which island he's in, but he publishes, he sells antennas, he publishes the design for all the antennas, and he also does a video on how to build all of them. These center pieces here, he is riveted to the center section and then screwed onto that. But all of the exact ends, all the tuning of it, and all the measurements are readily available on his website.
This presentation will be available.
It's on Groups.io now.
Okay.
Whoops. This same site, by the way, publishes all of the Smith charts to go with his antennas as well. So he's publishing the gain, how to build them, all the data specs behind them, and shows you from going from a dipole to a 2-element Yagi to a 3-element Yagi. And earlier when I mentioned that the backward gain on this 2-element was not as large as the 3, he's showing it there on the Smith charts. Wrong direction. And so basically, there's another website that I've listed up top that will actually do the Smith charts for you by putting in some of your design, so you can model the design of your antenna. It'll put out the Smith charts, and then it will put out the actual build of the antenna for you. Construction materials, I mentioned a minute ago. Can be a bicycle spoke, can be a welding rod, can be a piece of copper pipe, really just about anything you have around. These are made from an arrow. It's an aluminum arrow, and it's actually, I really like these a lot because with a piece of 832 screw that you put through a hole, they come together and they apart really easy. So all I had to do is do 1, 2 holes and cut these to length, and I've got the antenna, and then all I had to do is the gamma match. So a real easy way to build them. The only thing you need to be careful of here is you have to have continuity between these 2 pieces. So if it is a anodized aluminum like this one, you have to use a little sandpaper in order to get this particular part here to have continuity. But as far as building it, it's real easy to build. The arrows are actually extremely sturdy and nice way to do antennas. Or measuring tape. A $2 12-foot measuring tape, and it tells you the length to cut these 2 pieces. This one's 2 different pieces in the middle because you're going to match it to your feed line. My feed line is just soldered directly on those. And guess what? Measuring tape solders really well. It takes solder great.
Bill, it's not plastic measuring tape.
What was that? Got to have metal tape.
No, you do have to take the tape, you do have to take the tape off the area where the.
You sand off just a little bit before you solder to it, yes. Now, one of the guys in the Hearst Club suggestion, make sure you put electrical tape over the ends. He dropped one of these and cut his foot. So when you cut these, they get sharp, but you can cut this with scissors.
Can you round the edges off?
Not really, it's too thin. These are held on with pipe clamps, and it's PVC pipe. Another little interesting thing with this is the length of this PVC pipe can be used to tune this. So if you get it and it comes out, your SWR says, oh, this is 147, and you want it to be 146, you can change this length and tweak it. So there's some playing around you can do with it that's sort of fun. So here's the antenna. You got a 7 dB gain coming out of this antenna. Off the website, every one of the measurements, the 8 inches here, the 12.5 inches here, the length of each one of these, all well published. So real easy to make the antenna.
That just throw something in. That particular antenna also has a very deep null off of the back of the antenna that you can use for fox hunting. So you turn it around backwards and you find the null.
So this,
Point right at it.
fox hunt in April, this is a good guy to have. I said, member of the club, come in, you make it for free, do it at home, will cost you $10.
So how long of a tape measure you need to get, like 3 feet?
Actually, no, it's longer than that. I bought a 12 because I think that what you have on this is about 9. So I started out with a 12. Start with 25, you can build 2 of them. And it only costs about 50 cents difference on the tape
That's what I
measure.
meant to say.
You can almost get 3.
So now what we have is we've actually taken a 440 and a 220 and put the elements on the same antenna. Now, there are some problems with that. If you're using this as a single sideband on 2 meters, these will interfere with each other the way this is built. Now, I'll show you on a later slide, but if you move the 440 in front of the 2 meter, you've got a longer boom, but that solves that problem. But if you're talking to satellite, you want these two 90 degrees from each other. So now they look like this guy. And so the reason you do is it ends up on the satellites, the 440 is at a different phase than the 145 frequency. And so this one now handles both. And actually, you're going to hold this in your hand or on a tripod for a camera, and you're actually going to turn it as you track the satellite, because the satellite changes, it's spinning and its phase changes as you do that.
So you're kind of saying that was it.
Doppler's different. The Doppler shift is on the satellite. It's farther away from you when it's on the horizon, and it's closer when it's straight up. And so what happens is your frequency shifts as it does that. And there's about a 20 megahertz frequency shift from horizon to horizon. And so what happens as you do that is you actually have to change the frequency of your radio with one hand while you're holding the antenna with another. And if you can chew gum at the same time, you're in good shape. You can take the tape measure antenna and add additional elements to it if you want one with more gain to it. Not tough to do, not expensive to do. Now you got your 25 foot and you've got 2 out of instead of 3. And again, I'll have little web pages on the bottoms of these.
Does it always affect the beam width, the more elements you use?
Yes, it does. It's focusing it. I mean, if you think of it as that's what you're doing there is you look at the Smith chart, it's the same amount of energy coming out of your radio, or it's the same sensitivity. You're just directing the signals a little bit. All right, so this is off of the little fox hunt antenna of the website. The guy sits here and he tells you, hey, when you use an arrow, make sure you got good connectivity before you get started. You got a little screw in at the end sometimes, but he'll go through, gives you all the dimensions, tells you everything about it and how to check them. But again, easy antenna to make. I mentioned use copper tubing. Again, these are printed on a 3D printer. There are a whole lot of applications out there where the parts to build the antenna, they show you come off of a 3D printer. I have one, oh, actually this one. This one I did not use a 3D printer. I took a block of plastic and cut each one of these and then drilled a hole one way for the boom and one way for the element, drilled a hole to screw to hold this in place, drilled another hole to hold that in place, and I have an antenna. So you don't have to have a 3D printer. You can do it. On this one, you'd have to have a table saw. On this one, all you need is a drill. So depending on what you have in your garage, makes a difference. This one's boom is made out of carbon fiber in order to make it a little bit lighter.
Where did you get the blocks of plastic that you got?
Right off of Amazon. And I didn't put a link on that one at the end. On all the others, I have the parts list, but it's just polystyrene block that I bought, and I just cut it to make the pieces. Guys mounted this one on a tripod. And so you can use the tripod instead of having to hold it into your hand. Not difficult to do. Now, a nice variation on that is if you have a little rotor system you build, and there's a lot of applications out there using Arduino that changes the elevation as well as the azimuth, and you can actually build a rotor control this thing to track the satellite going across the sky. And I'm about 90% done with that right now.
But that won't do the rotation that you were talking about, does it?
Well, depends.
Okay. All right.
You're actually using a 3-axis rotor instead of 2.
Okay.
So back to that same site again. Now what he's done is he's turned half of his elements at 90 degrees on it. And down at the bottom, he simply tells you have a 3 divided by 2 times the wavelength to get to 435. He gives you some of the math behind it as well. This is where I was telling you a moment ago that if I'm going sideband, I take these elements, put them in front, and put them in the same orientation as the 2 meter. But if I'm going to a satellite, I don't have to worry about that. So that visually is, this is one of the antennas versus this one, depending on what you're using the antenna for. So then you have the antenna itself actually is a different reactance than your feed line. And so you need it to end up at 50 ohms for your feed line. And there are a couple ways to do that. This one is called a gamma match. And all it is a small piece of wire that is looped in here that does the function of changing this antenna and making it where you have a match to your feed line, so you have a lower SWR. This one is using a thing called a gamma match, and what this really is a capacitor. What I have here is a center conductor surrounded by basically a jacket from an RG8 that is an insulator, and this metal piece here is the outer layer, so I've created a capacitor. And then what I've done is conducts, so this has the center conductor of my coax comes in here, the ground is connected these two together, and then this piece out here, and so this now controls the two coming together, and if I move this around, I will change my SWR. And so I can adjust this to get the lowest SWR I can for the antenna. This one's for the 220. This one's for the 440. Sorry, not 220, 145 and 440.
So that antenna you have in here, that's a dual band antenna?
That is a dual band antenna. And so this is telling you if you're building a gamma match based upon what you want the length of this piece for the gamma match to be, how far you want this conductor on the end of the gamma match back to the individual unit. It gives you the math if you're trying to create a gamma match, which on 145, this is going to be 7.5 inches long, and it's going to be 3.5 inches long if you're dealing with a 440 antenna. Or you can do the math. So this was sort of a fun one. A guy in Arkansas built this little guy and ended up with a 14 dB gain. He was talking to repeaters 17 miles away using a handheld on 5 watts. Same concept again. You have your driven element, your reflector, your driving element, and he gives you all the little parts to build this out of PVC pipe. But that's if you really want to go to the extreme. So you'll see the parts that are printed on this one, and there's a location to get the design for those parts, are a little different. This guy, instead of using, why he didn't use it, I don't know. He didn't want to use a 79-cent piece of PVC pipe. He printed that on a 3D printer as well. You got to have uses for your 3D printer if you've got one. Thank you, Mark. See, can you bring me that antenna down there? The first one of these I found was this antenna. And just like the other ones, starts out, oh, I turned it a little, with a piece of carbon fiber in the middle. And these are all 3D parts in order to hold these different elements in place. Now, I thought I was being really smart. I made these out of solid pieces of aluminum because I was going to drill into them and put the taps in here to connect up my coax. And I felt, if I use a hollow piece, I'm not going to be able to drill a really good hole and have it hold tight, which was true, but it also doubled the weight of the antenna. So I went back and on the smaller pieces, I took a whole lot of them out. But that was my first of the 3D antennas. And it's actually a sound antenna, and it's strong, but it's really no different than this antenna at all. The same guy who did this antenna apparently caught a little bit of flack for how bulky it was. So he did another one out of welding rods where the center piece pulls out and the whole thing folds over to make a very portable one as well. This is the antenna that I started out with, the little 440 one here. And again, we have the antenna here. This is that part right there, getting it off of Amazon, the little $10 part. Now, what I really think is the right answer is this antenna combined with this 145 antenna down here, because this is really a good little 440 antenna. And you can just sort of marry the two together and come up with a nice answer. I'm getting burned out at building antennas though.
Therapy.
This is where somebody's taken two of them, put them on a rotor. Now, one of the fun things on this rotor, by the way, is this piece right here is a linear actuator. It just shoots the rod straight out and back and uses that in order to do the elevation on the antenna. And it's a nice little answer on the way to do it. So the workshop on the 12th, it will be here. And if you let me know if you want to build something other than the measuring tape, we can arrange for that. The measuring tapes, we'll have the stuff here to do. Just send an email to Mike in the back of the room so you can register, so we have an idea of who all wants to do it.
What time was that?
10:30 on the 12th. Yep.
Got a quick question for you. How important is the measurements? I mean, do you have a centimeter you can be off? I mean, what happens when you start getting little
Millimeters off will affect you.
millimeters?
And there's some articles on the web on tuning these. But these pieces are interdependent and not as critical on 145 as it is on 440. On 440, if you're off just a little bit here, it's going to affect your gain. It's going to affect your SWR.
So the higher the frequency, the more critical.
Yep. And so you really, you got to look close at your tape measure and make sure you're getting things exactly on there. I cut these a little bit broad, and then what I do is I take a sander and sand them down, but I cut them using a moto tool. Real easy way to cut them, takes a second and they're cut through, but I'll give myself an extra 2 millimeters and then bring it down from there so I end up with the exact size. I've got an antenna outside there that has an 8 dB gain on 145. It's got a 10 dB gain on 440, built with the arrows. So the rest of this that's in the PowerPoint is really just, here are all the parts. So if I use this extruded metal part, I actually took where the part was listed on Amazon. That one I found currently unavailable when I went back to it. But like my arrows, so 31 bucks on an arrow, but you're actually getting a package of, I think there's 12 of them, which is more than you need for several antennas. Oh, that's one of the interesting things. If you're doing an antenna like this one, you can have a piece that goes one long piece, but it's longer than 36 inches. Finding arrows longer than 36 inches is not easy. Finding aluminum at Ace Hardware longer than 36 inches can be difficult. So this one, if it was a non-isolated antenna, like my arrow antenna here, I can use 2 of them. They're getting screwed together here in the middle, and they make over 36 inches combined, but each one of them is less. When I go to an isolated one like this, 440, no problem. But when I go to 145 megahertz, this piece up here is difficult to get long enough, and it costs you a lot of money to buy a longer piece. Now you can take 2 of these, connect them together with a screw in the middle and make it look like one piece. But that's the one thing you have to be careful of, is that as you look at the measurements, and a lot of them in millimeters, you're going to find that you're over a 3-foot range.
So does the screwed together one work just as well?
Yeah, it does. As long as you get it connected electronically, you're fine. So I've just gone through and lots of the different parts. Come on. Oh, wrong direction. So whether it's tubing, whether it's the little piece I bought on the end, whether I use carbon fiber rods, Duplexer. This guy is set up for 2 runs of coax to come out of him. My handheld doesn't have 2 connectors on it. So you can buy this little duplexer that takes the 2 meters in, takes the 70 centimeters in, and puts it out to 1 connector. It's really a bandpass filter, but it allows you now to have 1 connection to your radio, even though you have 2 antennas sitting out there. And the way a satellite works, by the way, is you're going to listen only on 1 frequency. Typically, it's going to be the 440, and you're going to transmit on the 2-meter antenna. And if you have you can do it with 2 radios, have one of them just sitting there with the speaker on, and the other one you're talking into, or you can do it with 1 radio with a diplexer. And typically, they say it's easier to do if you have headphones on then. But you've got 1 radio that actually is full duplex, and you can be receiving on 1 frequency and talking on the other simultaneously. Those radios start at about $200, but 2 Bofangs are only 50.
So
Uh,
that's providing you want to communicate with an FM bird.
You know, you also have the ones that, you're usually not gonna
Okay.
fit in sideband birds
Yeah, if you're doing sideband birds, you're going to be using a single sideband radio. It's going to be a different setup. You're not going to be using the ones like this that are turned. You're really talking about going to a LEO, which is low orbit
Right.
at that point, or the International Space Station, which is also low orbit. This guy has some little metal pieces on the end of him that allow you to clamp on the center boom a little bit better. So where those parts come from. So really all the rest of the pages here were what kind of connector are you going to connect onto the antenna with, and what kind of screws you're going to use. And that was it. So
One more question real quick, going back to that last one about the millimeters.
Yep.
Was that strictly the lengths of the elements or was that the distance?
Both.
between them? Okay.
both.
all the above.
And, you know, if you think back, I made the comment on this one that I could change the length of the centerpiece on this tape measure one and change the frequency. You don't have to change it much, and you will change the SWR and move it around. So the measurements are all critical. The material you make it out of, it doesn't care all that much. But the measurements, it makes a very big difference. And whatever your director element is, driven element, the director in front of it is actually even more critical. And one of the things I'll tell you is after you build one of these, if it's not exactly where you want, this is the piece that you start fiddling around with first to move things. Yeah.
Jason asked, how exactly are you connecting the coax to the antenna?
So, oh, well, once you get the coax, it depends on whether you want an SMA connector on the end of this or PL239 on this. So my coax is coming, I've matched it up here. So I'm now 50 ohms, either using a gamma match or using a beta match like this. I'm now 50 ohms here.
Or VNC connected.
And so whatever connector you want to put on the end here.
Connect to the driven element is the question.
Solder.
Okay, soldered on this one. This one, see if I can, yeah, pull it apart. This is just a piece of RG8 wire, and actually this was probably 59. And I took the plastic off the outside, which I have my insulator, and I have my copper in the middle. And as soon as I put it in here, I've made a capacitor. And so now I change the capacitance by either changing where this piece is located or this one. And when you tweak this around, you'll end up getting 50 ohms right here. Any other questions?
So I'd imagine you'd be building these, we're using an antenna analyzer to make sure you got it so where it needs to be set.
Yes. So got a nano antenna analyzer, but that's a topic because we've just hit 30 minutes. 5 over.
One of the things you mentioned early on that's really important, you mentioned about having different antennas for different things. For satellite and regular communication, everyone's thinking about gain. When you get in the, one of the reasons the fox hunt antenna is so popular, which is just the 2 elements, is it kind of goes against everything you've ever thought about antennas. When you start getting close to a fox, you're trying to knock down the signal as much as possible. Once you get, especially if it's a high power transmitter, once you hit full, it's pegging out your S meter, you in all directions, you got to have some way to knock it down. So every more bit of gain you have is actually your enemy. That's why you have an attenuator in line. So that's one of the reasons that's more popular. You still get the directional element, but you're not overwhelming your receiver with that extra gain that makes it where you can't get any directional element out of it.
Yep, and Rich is going to teach us how to use harmonics to do some of that too.
Sorry, I didn't mean to take that.
No, if you want to get a head start on that, I've actually got some attenuated kits here, so we can talk about that. But if you come along and you build one of these things, then you're going to be ideally kitted out to do most of the box hunting we're looking to do in April. These things take not an awful long time to put together, but they're very effective. So, and you will need an attenuator. I'll talk to that in the presentation next month. You can either go online and buy one, and for the club members, I've got some here. Don't want to take them away and build them.
And one of the things that Bud mentioned is that as you do a fox hunt, there's a lot of getting in and out of a car, and having an antenna that folds up like this versus trying to get in and out of your car with this sometimes is a real advantage. Huh?
That's the advantage to a pickup.
Yeah,
I always have a
I've
pole going
seen,
through the
I've
skylight.
seen people rotating their antenna inside, they got their antenna sticking out their moon roof for their sunroof while they're rotating, while they're operating, trying to find a fox.
I've seen people mooning while they've been doing
The
it.
other question I was gonna ask, when we have our workshop presentation next month, are we also gonna be tuning the antennas?
Yes,
Doing a workshop to show how to adjust.
we're going to have an SWR there to sit and make sure that we're set for the right frequency with the right SWR.
So we're gonna be having an antenna analyzer there.
Yep.
Okay.
Yeah, I'll bring one out and you only have to pay $100 an hour.
If you don't have a nano VNA, they're really handy. I've got picked one. I don't know how I live without one for so long. I picked one up at campus and I've been using it like crazy.
So the important thing is Mark looks like he's had success in the time it took us to do the presentation.
Hey, Bill, what time? You said 10 o'clock for the
10:30
10:30?
on the 12th.
You said, I told everybody 10 o'clock.
If they show up, I'll be here.
Okay. So now it's being pushed back to 10:30.
One of the tricks I did or done in the past, I'll tell you about it.
Oh, that's all I had, folks.
Thank you.
That's all, folks.